Bismillahirrahmanirrahim. My name is Usama Zahid, and today I'm here to give my presentation on my current semester project, which is of machine learning. And the data set which I have chosen from the Kaggle is the digit classification. Let's proceed. This is the presentation sequence. First is the project requirement. Second is the Kaggle active competitions dataset. Third is the data pre-processing. Fourth is the machine learning model implemented and hyperparameters tuning. Last but not least, the conclusion. These are the project requirements which were initially shared by our worthy instructor. We had to select any Kaggle active data set, and the ethical requirement was that we will not look at the code at Kaggle. Then it will be the individual project. Everybody has to do this project individually. So I had chosen the digit classification related data set from the Kaggle, and it was an active data set. So what were the components? The components were that we have to run 5 to 6 algorithms. Then we have to do pre-processing of the data set, hyperparameter tuning, pipeline implementation. It was not mandatory. Uh, then we had in the last we had to do the 2 pages conclusion report. So I have tried with the best of my capacity to incorporate all these ingredients in my project. So this is the report which I have finally made after running various algorithms on the data set. I will be sharing with this uh, report along with this complete project. This document will be attached, and this is the complete Python code with all the algorithms implemented in Google Colab. So I'm just giving a dry run about how I have implemented and how my code looks like along with the outputs generated after varying various hyperparameters in each and every algorithm. So let's go in detail and let's see how I have implemented these algorithms and how I have reached which reached to the conclusion that which algorithm is performing better and what are the reasons. Let's move on. So as I have earlier mentioned that the dataset which I have chosen was the active dataset, an ongoing dataset, and it was a process dataset in which we had images of 10 different classes, that is 10 different numbers, and they were basically in binary representation that because the image is basically in 2D form, but the dataset when I read in Google Colab, I found that they actually done the reshaping on every image, and each image is actually a sort of a 1D vector with a dimension of one row and m into n columns, whereas the m is the number of pixels in rows and n is the number of pixels in the column. So the structure of my single record was basically 1 cross mn. So let's start with the data pre-processing. When I read my data set in Google Colab using the pandas library, uh, I found that the data set was basically imbalanced. So in order to balance the data set, I had to do some pre-processing. And one of the most promising methodology and the most applied methodology is basically the SMOT, which is synthetic minority oversampling estimation. Secondly, my observation was basically that the data was of each single element was basically the pixel value, which was either 0 or it was 255. So to be on the safer side, what I did was to normalize the data set so that everything should be between 0 and 1. So these were the data pre-processing which I had done. So after applying this moat, uh, which if you see on the left side of your graph, you see that all classes have not equal records. But after applying this moat, you see that all records were balanced for each and every class. So the L2 norm was applied when I did the normalization process. This is the snippet, code snippet of this moat. Uh, First, after reading my data set, uh, I actually sorted my uh, independent variables and dependent variables in X and Y. X was my basically, the feature vector in which I have placed all my feature columns and dropping the label column so that only the independent variables move to the X variable. Then I have applied the pre-processing in which I have done the normalization and the norm2, and the norm which I have used is basically the L2 norm. Furthermore, then the moat is applied on the imbalanced data set, which was actually placed both in X and Y, where Y is the target variable, X is the independent variable. Then again, I have replaced my, it was my previous X and Y, and the new X, Y were actually giving us the balanced data. That is, the balanced data was moved in X and Y. And so this is the code snippet of data pre-processing in which this mode was applied. So there were 7 algorithms which I have run to evaluate the performance of various machine learning algorithms along with the hyperparameter tuning. However, over this slide, you can see there are 6 different machine learning algorithms. Uh, but the seventh one, which currently I'm doing, is basically the artificial neural network. I actually since I have not obtained the best performance from the artificial neural network, because I have to, by hit and trial, I have to do the manual tweaking of the hidden layers and the number of neurons and type of neurons. So far I have obtained 94% accuracy through the artificial neural network, but still, as per my intuition, I believe that the artificial neural network has the room to give me better accuracy. But since I have to conclude my report, so I will still stick with the 6 algorithms which I have implemented and rigorously explored through varying different hyperparameters. Let's move with the let's go to the first one, which is the naive Bayes. Naive Bayes was not being taught in the classroom, but naive Bayes is one of the very basic and fundamental machine learning algorithm, and it is also a parametric algorithm, which actually gets the mean and variance from the different data of different classes. So as I earlier mentioned that I implement the pipeline architecture, so I will explain one by one. Over here, if you see, we have declared an empty array, and it is being shown through a variable estimator. Then in the estimator, I'm appending my first process, which is basically the standard scaler. Then in the third process, which is basically the model, which is basically my naive Bayes model. So all these processes are stacked in the pipeline architecture, and my the model, which is basically a pipeline based model, where I have stored my estimator over here. So estimator is basically having three processes, and over here what I am doing is basically putting the model on the train data and the train labels. Then I am doing my predictions on the test data, which is actually the X underscore test data, and then I'm finally evaluating my performance on the uh, since I have the reference of Y underscore test, I have those actual labels, and I have my